Okay, so we're looking at doing a little bit of math and some impedance again. So we seem to be having problems with trig and math and things like that. So here's the stuff you need to do the trig part. So sine theta is opposite over hypotenuse. Cosine theta is the, adjacent over the hypotenuse, and the tangent theta is opposite over adjacent. You'll also need this in power, but here's an impedance triangle. You have the imaginary part, could be in the first quadrant or the fourth quadrant down below. You have the real part, that's the adjacent, and then you have the hypotenuse, which is the magnitude, and then you have theta, which is part of the polar form of the number. In power, it's S equals P plus JQ, where S is the hypotenuse, P is a real number, which is the adjacent value, and the Q value, reactive power, is the opposite value. The other part you'll need is Pythagorean theorem, which says that the hypotenuse squared equals the adjacent squared plus the opposite squared. So that's the math we'll need to turn polar into rectangular and rectangular into polar format numbers. Okay, so let's take an impedance problem right here. We have Z1 in parallel with Z2, and we're looking for ZEQ. And Z1 then is 5 plus J5 ohms, and Z2 is 3 minus J4 ohms. And if we look at that, we see that on a regular graph scale, this is quadrant 1 again, and this is quadrant 4. Then we have a 5 ohm real part. We have a J5 ohm imaginary part. And then we can find the magnitude of Z1, which is this line here, and then we can find the angle of Z1. So the first thing we do is we're going to find the magnitude of Z1, which is 5 squared plus 5 squared. Take the square root, we get 7.07. I want the angle of theta Z1, and that's going to be tangent inverse of opposite over adjacent, 5 divided by 5, and that gives me 45 degrees. Again, cosine is an even function. You can't get negative numbers out of it. Sine is, and tangent is not even, so you're going to get negative or positive signs depending on what you input. Anyway, I get a Z1 polar form of 7.07 at an angle of 45 degrees. And Z2, if I do the same thing for Z2, I get a polar form of 5 at an angle of minus 53.13 degrees. Again, you put in minus 4 divided by 3, take the tangent inverse, and I get minus 53.13 degrees for Z2. All right, so I'm going to use the old format to find ZEQ for two numbers in parallel. So I'm going to do Z1 in parallel with Z2, which means I multiply Z1 times Z2 and divide that number by Z1 plus Z2. Now, add and subtract is easier in rectangular. Multiply and divide is easy in polar format. So here I go. I'm going to multiply those two top numbers. 7.07 angle 45 degrees times 5 at an angle of minus 53.13. So I multiply the two magnitudes right here. And I add the two angles. Pretty straightforward. And then in the rectangular format, I add 5 plus 3 gives me 8. And plus J5 minus J4 gives me plus J1. So 8 plus J1 right there. And then I keep on going down, do some more math. I multiply 7.07 times 5, and I get 35.35 at an angle of minus 8.13 over, or divided by 8 plus J1. Now this is a division problem now, so I'm going to take that 8 plus J1 and turn it into a polar format. So I use Pythagorean's theorem, Z in the denominator equals the square root of 8 squared plus 1 squared, which equals 8.06. And theta Z in the denominator is going to be tangent inverse. Once again, the imaginary part 1 divided by the real part 8, opposite over adjacent, equals 7.12 degrees. And I get Z in the denominator 8.06 at an angle of 7.12 degrees. Stick that back into my ZEQ formula, 35.35 divided by minus 8.13 divided by 8.06 at an angle of 7.12. And now all I have to do is divide the magnitudes and add the two angles. Now don't forget, you got to subtract that bottom angle from the top angle. And now what I have is 4.38 at an angle of minus 15.25 degree ohms. So this looks like it's in quadrant 4 because it's a negative. Quadrant 4 is an RC network. So let's just see if that comes out to be an RC network. So here we go. I'm going to change it back into a rectangular format. I find the resistor value is take the magnitude of Z, multiply it by the cosine of minus 15.25 degrees, and I get a 4.23 ohm resistor. And then I still don't know for sure what the X is, but I'm going to find X, the opposite value. Take the magnitude, multiply it by the sine of minus 15.25 degrees, and I get minus 1.15 degree, 1.15, not degree, it's ohms actually. And it's negative, so it's down in the fourth quadrant, so it's going to be XC, so XC equals minus J1.15. And says ZEQ in rectangular format is 4.23 minus J1.15 ohms. If I did it in my calculator, and the way I like to do it in my calculator, I would stick in Z1 as a complex number. I would do the parentheses 5 space 5, hit the invert button. Then I would do the second impedance. That would be 3 space, actually parentheses, 3 space 4. Hit the change sign button. Hit the invert button. That would also enter it in the stack. And then I just hit add. And that would add the two inverted numbers. And then all I have to do is hit the invert button. And I would get 4.23 minus J1.15 ohms. And that concludes this math. Again, you're going to have to watch out because you're going to be doing this with power. Is it in quadrant 1 plus Q, or is it in quadrant 4 minus Q? If it's in quadrant 1, it's an inductor. It's an RC network. If it's in quadrant 4, typically it's a capacitor, and it's going to be an RC network, a leading network.